All right, this is cool.
And start.
Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 108. Today we're talking about eulogizing Daft Punk helmets, Bitcoin feeling the heat, squeezing soft robots, and motorizing ice skates. Elliot, it is the end of an era, and for a different reason than you might think, Daft Punk split up.
Sadder, faster, better. Yeah, everything has to come to an end. Their last album was fantastic, though.
Yeah, the Random Access Memories from 2013.
Yeah, that was outrageous.
Yeah, that's definitely my favorite album by far. It's wonderful. If you haven't listened to it, go listen to it. It's just the right balance of like experimental music and the thing they do. I love it.
Yeah. What I liked about that one is it just sounds so gosh darn good. And behind the scenes, they actually, instead of like doing everything on computers, they actually got musical instruments and played them, which I know sounds crazy. And because they did this, they had to actually hire like studio engineers, which costs more money. And the whole making of that album ended up costing a whole ton of money. And then it sold so many copies that they made all that money back. It's like making records in 1985.
So I didn't bring it up so that we could walk down memory lane on the music, although that was fun. The end of the era here for us is the project of building Daft Punk helmets. I have a really special place in my heart for this, and I was so glad to see that Jenny does too, and jumped on this and wrote about some of these projects that we saw. And my theory, Elliot, is these robot personas came out right when the ability to like have a 3D printer of your own and do your own custom electronics on the cheap, and maybe even like build a CNC machine and like do molding and do vacuum forming and maybe get access to these tools at a hackerspace. It was like all in that era, and people kind of glommed onto this and were like, we can build these things. And it was the perfect storm of cosplay, electronics, and fabrication.
Absolutely. And LEDs. Do not forget blinking LEDs.
It didn't used to be so easy to blink LEDs. Back when these were first coming up, the LEDs were a non-trivial part of the project and people had to do clever things. And that's where it started. And the helmets are pretty good. And then as those tools and materials became easier, the replicas were every bit as good, if not better, than the real thing.
Well, you were going to talk about pandas, though.
Oh, yeah. So did you watch the video from Hari Wiguna in the comments of this?
I did, actually.
Oh, it's super fun. So if you have a moment and you need to brighten up your day, the link to this comment is here, and it is two pandas whose arms, legs, and head are on servo motors, and they kind of rotate, and it shows like a printed word on one side or the other side of the arm. And so the stronger, better, faster, louder, whatever those things are in the song, it choreographs with it. And just there's this one point where the two pandas slowly look at each other, and it totally takes it out of that robot thing and anthropomorphizes them. And I'm just like, aw, that was fun.
So what else have you been up to? Have you been hacking up on anything lately?
Have I been hacking up? I have been hacking up digital price tags. So I got one off of the eBays, the Electronic Bay, and it's a Pricer brand 5.83-inch e-paper price tag in a nice little molded plastic case. And I cracked it open, and it's got a good display in it. It's a 3-color display, and I was able to drive it, but not with the 3-color display driver, which is weird. I was able to drive it with the 2-color display driver, so I only get black and red, but it at least proves that, we can drive this display. It's not some secret sauce. So then I started going to look at how I would fix the 3-color driver, and that is a nightmare, Elliot.
Why is that?
The drivers are just so different. Like, you can find drivers for Raspberry Pi and for MicroPython and for C, and you can look in them, and they do things very differently. And they have these lookup tables that are basically the waveforms that the panels need in order to move the pixels around. And so those are very important, like the waveforms and the timings and the voltages. And some of them it's missing from libraries. Others, it's just different in the libraries. And so, I had one library, I'm like, oh, this one's going to work. And then it doesn't do that flashy thing, where it does like white, black, screen refresh. Yeah, well, it just immediately shows the image. And the thing is, that's great, except for it's going to damage the display over the long term. So, wow, don't look under the hood of ePaper because it can be a mess, especially for kind of these oddball panel sizes.
Have you seen some of those LilyGo boards around?
I have. So I got one of so they're from TT-Go, and I got
Yeah.
one of the TT-Go LCDs, but I looked at getting the LilyGo ePaper one and decided against it. Do you have one?
I don't. I'm super interested in getting one though, because they have a red, white, black one and they look super sweet. And we just put out a project with one wireless, low power e-ink weather gadget. And the interesting thing about this one, and this shows up in the comments too, is that the thing, although it's an e-paper display, it has a bunch of poor power choices on there that make it drain power aimlessly, basically.
Oh no.
And we got into a good discussion in the comments on there. Nomuza came up with a really nice project and linked to it. It's basically using it as the label for an ever-changing picture frame. So he has it like, like if you go to a museum, underneath it, it says what the piece is. This does that. And so he printed up a nice enclosure for it. Really nice project, except it runs out of batteries in a few days, even though it only wakes up once a day to get a message and put it up there. And you can see him in the video covering up the little green LED that the thing has with putty so that it doesn't backlight itself green. And that turns out to be the culprit. It's got about a 7 milliamp drain because A, it doesn't shut down the SPI memory, and B, it has this green LED that's running all the time. And if you put the ESP to sleep, it'll have, it should last for months. But if you put the ESP to sleep and leave the LED on, it should last for about 7 days. Boo. So if you have one of these and you're looking at battery operation, you should definitely dig into the power management. And I'd love to see someone do a good write-up of that.
What does this cost? About $23? I don't know. What's the shipping on that? Anyway, we're on a show, so maybe I won't be shopping. But
thanks.
So this is more than I paid for that price tag. But
Right.
I was thinking if I could get this board cheaply, the ribbon cable is going to be the same for the display I have as it is for this one. And if it's a 2.7-inch display, then it's hooked up the same way. It's got the same signals that you would need. So you just need to change drivers. So it would be interesting. It would be cool to find like a universal driver. I guess that was what the WaveShare boards are. But these LilyGo boards, if they sold them without the panel, they'd be super cheap and you could just add them to whatever panel you have. Anyway, I digress. It's fascinating because these are fun to play with, and like that challenge of like why the driver doesn't work or why it's wrong kind of itches my brain, but boy, I'm down the rabbit hole now.
My first hack this week is a CAM program that is computer-aided manufacturing, and this is open source CAM software in the browser. In particular, we're talking about Kirimoto, which is written by Stuart Allen. And it's a surprisingly competent computer-aided manufacturing software. I actually went and tried it out. It's really lovely. It aims to do kind of everything. So if you've got a 3D file, it wants you to be able to slice it for an FDM printer or an SLA printer. Or it wants you to be able to create a toolpath for a CNC router, or a laser cutter if it's a flat thing, or a drag knife if, it's a sticker design. It looks like it can do about everything. It's a pretty sweet interface, and I'm actually pretty turned off by a lot of these programs that you have to use remotely. This one uses your browser as an interface, but it isn't necessarily in the web, which is to say, you can go to the GitHub, download everything, run it on your local computer, and you're good to go. So it's an awesome way to kind of leverage the graphics processing power that you've got in your browser and give you a pretty sweet and user-friendly looking CAM program, completely open source.
So Elliot, I know that you just built a drag knife attachment for your CNC machine gantry.
Yeah.
Are you using this program for it?
Okay, so I won't lie. This is why I'm so interested in this and similar things. And I've actually got into FreeCAD a couple weeks ago, and FreeCAD is hard. And it's a CAD and CAM. So the CAM part of it does make nice toolpaths, but then you have to learn the whole CAD part just to do it.
Right.
The nice thing about Kirimoto is you give it a 3D file. So you do your CAD however you like to do it, and then you hand the file off to Kirimoto, and you can use its path planning and slicing and whatever else you're into. In the comments, this one, a couple people have mentioned some other CAM programs too, and it's getting to the point where there are a ton of interesting, competent looking CAM programs out there. And so if you want a really minimalistic one, I was pointed in the comments to this Crabs cam. I'll put links in here. It's really sweet if you just want to quickly bang something out, but it's underpowered if you need to do like super complex path planning. And then also later in the comments, Bruce came along and pointed us to his list of current open source CAM programs out there. And that is worth chasing down because I've been looking for just exactly such a list. And most of the ones I'd found are so out of date that they, list programs that have been abandoned 5 years ago or something. Whereas Bruce's list is really fresh and really on the money. That's a good place to start. I don't know what I'm going to use for my personal CAM needs now, but it's so awesome to have some really simple ones that work really simply when you just need to do something quick, and then some fancier ones. The capabilities of FreeCAD's CAM are just out of this world, but you got to put the time in to make use of them.
I loved this project called Shredding the Ice with Powered Skates. Danny Conradi picks it up from the RC Life On YouTube channel. Simon is just doing an excellent job of prototyping and fabricating motors for the back of ice skates. Now, I used to live in the Great White North, and I used to own my own skates, and you could go skating outside all winter. That's not quite the way it is where I am here, but if you watch this video, Simon's got a whole lake to take on with this project, which makes sense. That's why you'd spend so much time on this. Does a beautiful job of taking some motors that I think are designed for electric skateboards and attaching them through 3D printed parts to the back of the hockey skates. And then I love this, making them snow tires by taking some screws, cutting the screw heads off, chucking the thread part of the wood screw into a drill, and then just drilling them into some pre-drilled holes on the wheels. And the thing does pretty well. It zooms them around the lake.
Yeah, this guy's videos are always fun and always mayhem. What I love about Simon is that he takes on projects that are a little bit too big and pushes them through anyway, and shows all the missteps along the way, which are usually pretty funny. Doesn't end up drowning himself in an icy lake. So that's a winner.
It's super sloppy and wet though on the last day. And I think the day before that, he has to go and shovel a path around the lake too. So, someone's got to shovel this stuff off. But I love this quote. I had to write this down, Elliot. I'm looking really stupid with the wires, but it's homemade. So what are you going to do?
Yeah.
I love that. It's excellent. He has these wires for controlling and feeding power to the motors on the back of each heel, kind of snaking up to a backpack that he's wearing. And on the first day, the power and the control wires are separate. So there's 4 of these wires going up to the back, and he looks like a cyborg. The next day, he has some of those cable wraps to wrap them up. But I mean, all in all, what an excellent build. And I gotta say, the actual fabrication process is a perfect snapshot for the pandemic hacking times, because he's out in the winter on his porch in sweatpants in an N95 mask grinding stuff with an angle grinder. And I'm like, yeah, that seems about sweatpants and an N95 seem about right.
All right, here comes another YouTube hack. James Bruton's pool noodle robot shines a light on the pros and cons of soft robots. I love this one because soft robots always strike me as a good idea, bad idea, combined. I don't have any uses for soft robots, and most of the proposed uses are underwater or in space. I think the one way I can think they're useful is making grippers and things that have to grab soft objects like eggs or something. And that's one spoiler alert that James goes into in this video. In this video, he's building an interesting take on the soft robot idea. Usually you have a pump in there, and that pump inflates a bladder or something, and that makes it bend or actuate. Here, James is copying a project from Stanford where they filled the balloon and then had rollers that would move across the balloon from one side or the other, which would essentially make higher pressure in the one side and lower pressure in the other, and that would do the actuation. James's take on this is, instead of rolling along the balloon like, you never roll along the middle of sausages. I don't know what this would be like. Instead of rolling along the balloon, he puts bellows at one end, and so he can squeeze part of the balloon or let it go, and that increases the pressure inside the balloon or doesn't. And in his case, extends the little arm or leg. And it's really fun because he goes through this process of prototyping out what you can do with these arms and shows them in all different ways. And, it's kind of like kicking, and it's folding, and it's grabbing, and he's clearly just, exploring the shapes and what you can do by squeezing on essentially long, skinny, I guess they're pool noodle balloons.
Yeah, I mean, he does an end run immediately around one of the hardest things on soft robotics, which is making the bladders in the first place. So I love it that he's found these, mass-produced things to take economies of scale and put them together. And then the bellows thing that squeezes them that you're talking about, it's the same for each one. So once he has one design prototyped, he just, lets his 3D printers run, and he comes back the next day and puts, 6 or 8 of them together. In the end, it's the weight of that stuff that kind of makes it an unfeasible thing for locomotion. But you remember when we were at Chaos Camp and they had that tentacle that was like air filled? So it had 3 bladders in one tentacle. And so if you let the air out of one bladder, this tentacle is pointed up in the air about 15 feet.
Yeah, I was going to say, Mike's hiding the detail here. This thing was like 4 meters tall.
Yeah, super giant. Anyway,
yeah.
Like that's a soft robot right there. And the fabrication of it was difficult. And then once you figured that out, it's just controlling that air pressure that's in it. And I think this is a novel approach. Like he started at the beginning saying most of these things are pumping pressurized air into something, which means you have to have air storage and something to, a pump in order to fill that air storage up, and then valves and this and that. So this bellows mechanism, which is just one servo per actuator and then a little bit of elastic to return it to its bent position, is really novel. I'm sad that it wasn't stronger.
I mean, strength to weight is the limitation of all of these. And James points it out in the beginning that all of the research soft robots are powered by a compressor that's off board. So they have like air hoses running to them because the pumps that you have to use to turn the pressure on and off are just too big and bulky, and they're power hogs, they're inefficient. You don't want to have to carry these around on your back if you're a little inflatable robot. And so that was part of his inspiration here, was to try to get something that could move around on its own, carrying its own bellows and servos and whatever. As Mike said, unfortunately it can't, and it's not for lack of trying. He tried to make a hexapod. That didn't really work, so he tried an inline kind of 3 legs on a side robot, and that didn't really work. But still, along the way, there's a bunch of neat little implementation details. He makes these awesome clamps that use non-friction sticky pad inside some regular bar clamps to make the legs hold on to the rails and stuff. It's really, video's worth your watch, even if you don't care about soft robotics. In the end, he settles for a gripper, which is kind of the obvious thing to do anyway. So it's got 3 of these kind of bent pool noodles that when you squeeze them, they straighten out and grab something small, light, and softly do so. And that looks like it actually works pretty well by the end. He has it picking up a little, toy basketball. Well, I'm really glad that he both shared all of the "this robot can't do that" things. But then you have to be happy that he got to the success at the end of making a working gripper.
JSig is making it a lot easier to put your art designs on your circuit boards. This is a program that he's coming up with that he calls Gerberize, and it takes SVG files, or it can also take JPEG and PNG files, takes image files, and it converts them into something that can be merged with your existing Gerber files. And the plan is that it won't blast out things that you already have there. So if you have a pad, a via, or a trace on the layer that you're trying to merge to, it's going to do the isolation for you.
I couldn't actually figure out what it was about. I thought at first it was about changing the shapes of the boards, but it looks like it's mostly just about putting really awesome artwork on top of them. And so it looks like It's to take your SVG artwork and put that on the silk screen and resist and whatever else layers. And he has an example, I guess it's in his GitHub, that's just stellar.
Yeah, and so I think if you have traces already on your board, but you didn't do fills, you can give it a Gerber file as the input of that layer, and then you can give it the art that you want to put on, and it'll overlay. You have to tell it like what size that art is going to be on there, and it'll overlay that on the existing Gerber without disturbing what's already there. I gave it a try. I thought it was a lot of fun because there is a way to do halftone, or maybe you might call it stippling. Do you know that art thing? So it's like if you have a bunch of different size dots, you can put those in a way that the larger dots make a darker aggregate in that area, and you end up having an image that is basically grayscale, even though you only have two colors on or off, right? So it's what newspapers used to do back in the day. In this case, I really liked it because it has a bunch of different options on the type of halftone that you did. I will put an image in the show notes that I did. I put it through the hex filter, and I didn't get to the point where I was trying like a bunch of different layers with a bunch of different colors. But like you said, he shows an actual circuit board that he had produced, and it's pretty small. Like the resolution on it came out really great. It's about the size of maybe a fifth of your keyboard. There's a keyboard for scale in it.
You can't talk about PCB art and making it out of SVG files without me thinking of the lovely package SVG to Shenzhen. If you are interested in not just putting art on the PCB, but making the shape of the PCB artistic, you should absolutely go check that out. That's a classic. And I have to think that if you started off with SVG to Shenzhen to get the outlines and the layout like you wanted, and then coupled that with this Gerbalized thing, you could make fantastic looking silk screens on top of an awesome looking board. And I hope that people start using these together to make super crazy art.
I think it's really useful. Some of the coolest things that I've seen, I suppose we should pull these links in, but Jenny did an article about Camp Zone badge that had really beautiful art on the front of it. And then I also remember seeing that e-reader on Hackaday.io where the instructions for the thing were on the back, but they were like just text. They were like in an artistic script. And I looked at that, I'm like, that is totally how you should do documentation for something that's just going to be a bare circuit board without a case.
All right, my last hack, I have an audio quiz for Mike. You ready?
I'm ready. Go.
Hackers of a certain age will know what's going on here. What is this?
Rotary-dial telephone?
Exactly. This week we have not one but two rotary-dial telephone hacks, and I thought I would use one to feature the other. The first one is the 70s are calling to shed some light. Dubchinsky took an old rotary-dial telephone and basically made a desk lamp out of it. What's completely charming about this is that the handle, the receiver and mouthpiece part of it, actually has the light in it. And so it's like floating up in the air above the body of this phone and lighting up his desk. I think it's absolutely fantastic. The comments went wild with people saying what you should do with the dial on the phone and like crazy ways to make it dim the lights. If you dial 2, it gets dimmer. And if you dial 9, it gets brighter. I think that's all lovely. There are a bunch of fun things you could do with a rotary dial phone. The one here, actually, I used to have hooked into a password typer for me. So I would dial 29 and then it emulates a USB keyboard and would type a password in for me. I haven't used it in ages because it's just too damn big and it takes up half my desk. But I did that so long ago that I had to play around with the pulses myself. But nowadays, if you want to make a rotary dial cell phone hack, there's, of course, an Arduino library for that. And Harvey's rotary dial library will get you set up. You pull that down off of GitHub. I'll throw the links in the show notes. Which brings me to the second rotary cell phone hack. It's so beautiful. Simplify your life with this pocket rotary cell phone. It's a 3G cell module combined with a microcontroller on a custom PCB with a rotary cell phone dial attached to the front of it. This is a project by Justine Haupt, and it is phenomenal in terms of fit, finish, look. You have to go click through this one, see how she did it. It's the sort of thing that you would definitely want to have in your pocket, except you'd have to remember everybody's phone numbers to be able to dial them.
All right, let's move right along, Elliot. I want to do this art project that I wrote up called Morph. It's actually called Morph version 2. It is a larger and much more technologically advanced version of the first one. It is a giant LED ball on a pedestal, but every one of the hex tiles that make up the surface of this ball have a linear actuator in there so that they can move in and out from the center of the orb. And the animation that goes into this, both in the color of LEDs that light up the hex surface and in how these hexes move relative to each other, makes it look fake. It looks like CGI. Yeah, so Nicholas Perillo of the company Augmental and Mindbuffer got together on this one, and we're seeing like a pre-release of it. I don't have information on where this is going to be shown. You know, it looks like, I don't know, it looks like a Burning Man thing, but it's not gonna, you know, you're not gonna take this outside into the dust. I'm guessing it is a museum installation, but wherever it is, I'd love to find it. It's being shown off where it was built, which was at Motion Lab Berlin. This one's actually a little hard to get information on. The demo videos came from Twitter, but then you have to hunt around a whole bunch to see any build information on it. And the best place that I found, I think you're going to need a login for Instagram to look at, but there's an Instagram story linked in the article that does a great job of going off a full year's worth of development on this thing. And you see the pain that goes into, you know, inserting thousands of heat set threaded inserts into 3D printed parts. They did PCBA, but you have to unpanelize all the PCBA. You see they must have ordered cables because all of these things have to be connected together. There's a board on each of the 486 stepper motors that power these things.
Right.
That has to connect to another circuit board that's on the end where the LEDs are. So there's 86,000 LEDs in this thing. And then it actually, inside of the welded frame that's holding everything together, you don't see, are speakers. So it also, you know, is assaulting your senses, not just with that motion and the color, but with audio all at the same time. I really got the feeling that practical effects still have a place in this world, because when you see the renders of what the animation is going to look like and then you see it actually running on the ball, you just can't do that with the computer graphics. I think if you're standing in the room watching this thing happen and you can move side to side and see it, I mean, even on the videos that we look at, they're great, but you know, it takes it to a magical level. And wow, I can't think how this could have been done any better than it was.
First up on Quick Hacks this week, I have Attack of the Flying 18650s. David Cleeden has made a drone that uses, instead of those little pouchy LiPo batteries, regular old 18650 cells, like the ones you've scavenged out of that old laptop. In the last few years, people have been doing a lot with like long-range FPV things and drones with 18650 cells, and I think we're seeing right now a turning point to where you can just slip in these commercial cells into wacky flying things, and I welcome the new era. Next up, Amy makes stuff. Chen, machining a honing jig will keep skills sharp. This is one of those little rolling honing jigs that you use to like sharpen a chisel. I have one. They're a phenomenal thing to buy. They're really cheap. And she actually mentions this as she's making this completely handcrafted, hand-milled, lovely piece of work and says, yeah, they're cheap, but then I don't get to machine anything. She was at SuperCon showing off her flextures, and I didn't know she had a video series. This one is a phenomenal bit of machining with all sorts of tricks and tips along the way. It's a great watch. And last up, Thomas Sandlatterer, Fail of the Week, How Not to Build the Filament Extruder. 2 weeks ago, we covered his filament thickness sensors, which basically he used to prove that filament these days is really pretty good and you don't need filament thickness sensors. This is the project that he, in the period from 2013 to 2015, needed filament thickness sensors for, and that is making his own filament extruder. He goes through why it failed, and the main reason, I think, is that he tried to have it be essentially commercial speed and industrial grade. But he goes through the design, what worked, what didn't work. It's really great to see. Again, like his thickness sensors, I think that the state of bought filament these days is good enough that unless you have really special needs, you will not be building your own filament extruder. But you should totally have a look at this to see what goes into it.
First up on my list of quick hacks, 3D printed macro pad ditches the PCB with slick wiring guides. This project by Does It Better is a 3x3 mechanical key keyboard. But the cool part is the base is 3D printed, and inside it has traceways for wires to be put in. And at the end of each traceway is something like a boss where the wire goes in and turns 90 degrees up into the air. And it's just in the right place so that, say, once you have all the wires in place, you can take your Raspberry Pi Pico microcontroller, lower it right down, and those wire tails are going to go through the holes on the board, perfect for soldering. Next up, DIY all-transistor addressable pixel. Tim, CPLD CPU, has decided to make a discrete transistor type of WS2812 pixel. It's not exactly the same, but it uses an oddball timing scheme for passing ones and zeros down the line, and he, like the madman that he is, has made several of these pixels and is showing them off. And finally, we have a long-form piece of content that I'm putting in Quick Hacks. What? We spent a lot of time talking last week about wind turbines in Texas and talking about the cold, and Hackaday's Brian Cockfield decided to write about this. Brian has previously worked on these type of turbines and has some background knowledge on it, and talks about the different climates having different effects on turbines. So ice is one of the things, but more importantly, keeping the things from overheating is difficult. It's really interesting to see the inside knowledge on this and learn a little bit more about these awesome wind generators. It's time for our Can't Miss Articles of the Week. This is long-form content written by excellent Hackaday authors, and I think you're up first, Elliot.
This week, I picked Christina Panos' thought piece, What If I Never Make Version 2? This was a lovely article about prototyping and what choices you make when you're making something for practice or the first version of something you maybe want to make again, and how those choices affect what you have at the end, but then also whether you do it at all. It's got tremendous resonance in the comments, and a bunch of people have really taken it to heart and started reflecting on their own working practices. I love that. Basically, Christina wanted to make a backpack, and so she made a practice backpack. And she made it with kind of whatever fabric she had around and, the wrong zippers and a couple things like this, because she was telling herself, this is just going to be a practice backpack. But it actually ended up being so good in the end that she kind of regretted having not used the good stuff in the beginning. And so she's learned what she needed to learn from it. And so that, of course, is a success either way. But at the end of the day, she's got a backpack that she's a little bit less than fully satisfied with. But because it basically worked, she's also in this point where she's not 100% sure she wants to just do the whole thing again, but this time with the good stuff. And so her question is, when do you know to start off with the good stuff? And when do you know to kind of cut corners? Because if you had to invest in the good stuff, you probably wouldn't think it was worth doing, and you just would drop the project from the beginning.
It's a tough thing. I think everybody listening right now encounters this. I mean, one of the parts of being a hacker is that you're feeling thrifty about a lot of things. So if you look at your scrap bin and you see that you have perfectly good material there, you think, well, I should definitely use that for this project instead of, buying another. But at the same time, I do think for most people, time is the most valuable commodity. So yeah, Christina learned a lot about this, but let's say 85% of the things that she built going into it were exactly the way that she wanted them to go. And 15% of them needed to be done again. If she had gone with the more expensive material, that would have made her really love the finished product because it had the pattern or the feel or, you know, the use case that she wants for a daily driver. I think the cost of wasting away 15% of that material is definitely worth it. The problem is it's really hard when you start at the beginning of the project to know that that's going to be how it turns out. And you're not going to have like 100% waste on it.
The funny thing is you said time, and that's what always makes me cut these corners and skimp on all of this. I'm like, oh, I gotta get this thing done. I use whatever is in my closet right now to get it done, and that's pretty much never the right material.
Yeah.
I was thinking back to the Logic Noise prototype board that I made because a couple other people had made one recently and were asking me questions about some of the design. I don't know if you remember, Mike, you wanted to have it for a trade show. I had to get it done in like 2 weeks and get it shipped to you in America before you flew off to China or something.
It was China, yeah. We were taking examples for the booth, and that was definitely the winner because people got to build stuff and play with it themselves.
But that was crazy because I had this like super time crunch and I needed to get it prototyped and I needed to get the PCBs made and I needed to get it shipped to America. And so I just used whatever crappy stereo pots I had in my closet. And it turns out they have like this crazy, unique pinout that nobody else has. They're spaced out differently. The pins are thick. And so I'm sitting there measuring them with my calipers. I make the footprint. I send it out. And I have, to this day, never been able to buy another potentiometer that fits this pinout. And so I've had to make adapter boards for it, for myself, for other people, to fit these in there. And it's haunted me ever since. And this is one of those things where I think I'm kind of the opposite of Christina in that I'm not worrying about what happens if I make it too good. I just get it done and get it out the door. But then after the fact, sometimes, not very often, but sometimes it bites me.
So do you generally assume that you're never going to make another one?
Oh, that's a neat question. I usually don't is the problem. I often make things good enough, in big air quotes, on the first try that I'll just leave it. And of course, that explains why I have some like totally half-baked ugly hacks all around the house. But do I ever assume that I'm going to make another one? No, and I'm really bad about that. I rarely design for other people to make them too, because when you do that, you have to be in another kind of mindset. You have to think, you know, where can I get these parts cheaply? How can I make this easy? How can I make these connectors available and affordable? And, you know, you have to think about more than just kind of yourself and what you've got in your junk bin. And that's a different constraint. And so I don't actually do enough projects in that mode. I really should. It'd be good for my personal growth.
I fall into the classic trap that Christina is outlining, which is I assume I'm working on a proof of concept. And then the vast majority of the time, that proof of concept hangs around in a functional form that gets used for years and never gets a second revision. Yeah. And so I wish, you know, I'm like you. I'm like, okay, what parts can I get overnight at, you know, the next day or something? Or what can I buy locally? What can I steal out from something else? You know, what do I currently have the tools on hand to fabricate this particular thing that I need with materials that I have? Just wanting to get it done, but assuming that that's not how it's always going to be, that I just need to make sure it works. But then, yeah, I don't generally go back. And I think the other thing is I get so behind and I feel guilty on like documentation, because when I'm going through these and I'm assuming I'm just trying to see if it works, I assume that I'm going to take better pictures and write it up with better information when I'm, you know, do it for real. And then that never comes around. And
version 2.
Yeah. And then I'm left going, wow, I didn't even write down or take pictures on how a lot of this stuff works.
I wonder if the opposite of Christina's situation would help people like us. That is, if we spent up front for the good stuff to build the project with, or, you know, even just committed to spending up front for the good stuff, would that make you design more carefully and maybe even document at the get-go? And then, you know, would the kind of guilt of having spent so much money on the parts push you to polish it up a little bit more?
Maybe. But probably not. Probably I'm just going to keep doing things like I've been doing.
Probably just
but I
waste
like
money.
the question.
Probably just do things exactly the same way and just throw a bunch of money out the window.
Well, Elliot, I got to close the show by talking about Bitcoin. I'm sorry.
Oh, dude.
How many Bitcoin are you currently holding on to?
The same number as before, unfortunately. My Bitcoin portfolio has not changed in value since day one, unfortunately.
I'm not holding on to much Bitcoin. I wish I had a Bitcoin, but I do not have a whole Bitcoin. Jenny wrote an article this week that's kind of an interesting one to think about. And I've obviously seen the headlines everywhere, and I'm not sure I really totally agree with it. There's some calculations going around about what kind of energy cost the Bitcoin network actually accrues. And that's because in order to do transactions on a blockchain, you need to have a bunch of peer computers calculate hashes on the transaction and then verify among themselves that they got the answer, and then it gets recorded into the next block update. And this is apparently worldwide taking about as much energy to perform as the entire country of Argentina.
This is the problem and the brilliant thing about Bitcoin, right? It was designed from the beginning to have this like slowly increasing scarcity. And the method to do this was increasing computational complexity over time. You know, as more Bitcoins get mined, it gets harder to mine the next one. And so it kind of had this built-in scarcity, which is something that you need for a currency to have value. If you think of like why people used to use gold, it's because not everybody was just swimming in gold versus like dirt, which wouldn't make a good currency at all. There's a couple other things, and as Hackaday's resident economist, when Jenny asked the question, what makes a currency, she missed out on some of the good economic bits. My favorite of them, and Bitcoin fails this test, like a fiat currency is always useful to pay the taxes in the country that you live. Like if you live in the States, you can't pay your taxes in euros. You can't pay your taxes in Canadian dollars. You have to pay your taxes in green US dollars, or else you go to jail. And that's the real difference between a dollar and a Bitcoin, is that at the end of the day, the government will put you in jail if you don't give them enough dollar bills at the end of the year. I guess since money stopped being based on the gold standard, this has been the kind of thing that keeps our national currencies valuable, is that you have to render unto Caesar in exactly these bills. And Bitcoin, not so much. On the other hand, it lets you do a bunch of kind of online, international, documented transactions fairly easily. So that's actually a really interesting feature. But the problem of this scarcity curve that it has at the end is that we're kind of getting there, and we're kind of getting to the point where it's becoming extremely expensive to maintain the system in terms of kind of computational power. And I don't really know how it's all going to end.
So my question is it possible your home's furnace is going to be a Bitcoin miner?
Right. It makes sense. You've got to waste the heat anyway to warm your house. You might as well waste your heat by crunching Bitcoins.
Yeah, if you're just going to take some natural gas and burn it in order to keep your house from freezing, why not get a bunch of crypto mining rigs? And that's exactly what happened in one of the projects that we've seen this week, which sparked a ton of conversation on there. Christian Hoschek had figured out a way to use basically a heat exchanger in order to preheat the air that is going in and out of his house with his mining rig, while at the same time cooling his mining rig. I wanted to end on this one just because it's a little bit more lighthearted. So someone on one of the comments of this article actually said that, you know, if you are doing this, it's great in the winter, but then in the summer when you need to cool your home, it's a different purpose. And this person said, well, you just need a partner in the Southern Hemisphere, and you can ship the mining hardware back and forth and connect it based on seasonal winter.
People make heat by running electrons badly through coils of wire. Like, it could be worse.
That's like an Onion article, right? Millions of people are wasting heat on resistive coils in their home or something like this.
When they could be crunching Bitcoins with that energy. I mean, you still get the heat out in the end.
Mystery of Bitcoin shaming millions of Americans for heating homes with inefficient wire coils rather than Bitcoin rigs. That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment in the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday. We live and die by the tips that you send us, so if you've done something cool or you see something cool, let us know about it. tips@hackaday.com. And until next time,
keep on hacking. I have to sign back into Google.
As the ritual continues.
Oh, for the love of God, I have to do a CAPTCHA.
A CAPTCHA?
N-O-I-C-T or L, I can't tell. L-I-S-T-I-M-E, maybe. Failed the CAPTCHA. P-L-E-N-M-A-N-C. That was a good one. I hate this.
Is that the end of this one?
Diggadoo.